In this section, we'll talk about how to sketch graphs of sine and cosine functions. So suppose we don't have any idea of what any of those graphs look like. One strategy to figure that out would be to make a table of values. So you can start by making a table of values. Let's say we start by uh, with the sine. Let's say we start with sine. So you have a bunch of special angles you could use. Um, it is not strictly necessary that you use special angles, but why not, right? We know those. So you make a list of all the different values and all values of the angle and all the different values of the sine. And then you have a bunch of pairs, ordered pairs that you can plot. And if you plot them, and you can go past pi, there's no reason why you can stop at pi. You know, you can keep going around the circle, and those are keep using all the other special angles. You can after plotting them, you can see that the graph actually looks like this. And this is a plot of all these points. So this is all these points plotted, but actually keep going a little bit further. And this is the part of the graph that starts at 0 and goes all the way to 2 pi. So it looks like that. All right. And there are several important points that you need to remember. First of all, sine of 0 is 0. Okay, so you can think of it as saying like the graph starts at 0. This graph actually goes on forever in both directions, so it's not really a start per se, but that's why I like to think about it, because this main piece that you see right here is like, this is going to be like the main part that you need to remember or memorize, because the graph of sine and cosine turns out to repeat itself infinitely many times following this same pattern. So this is like the main pattern. So the main pattern starts at 0, 0 at the origin. Then right at pi over 2, you get the highest point of that curve. We call these like a wave. We call these the sine wave. So this is the graph of y equals sine of x. And then at pi, you go back to 0. And remember why those things are true. It is important that you don't forget why these things are true. If you remember from the unit circle, the cosine and the sine are the coordinates of the point on the unit circle that correspond to the intersection of the unit circle and the terminal side. So for example, pi over 2, it would be this angle right here. Right, it's a 90-degree angle, and the coordinates of this point, that's my angle. The coordinates of that point are 0, 1, and the first coordinate is the cosine, and the second coordinate is the sine. So that tells me that the cosine of 0 is, the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So the sine of pi over 2 is 1, which is what is right here. And similarly, if you have the angle that is pi, or 180 degrees, the coordinates of that point right there are -1, 0, and that is the cosine, and that is the sine. So that means the cosine of pi is -1, the sine of pi is 0, which is what we have right there. All right, and then if you keep going, you would get that this wave reaches the lowest point at 3 pi over 2. And again, this is 3 pi over 2. The coordinates of that point are 0, -1. So that means the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is -1. Okay, so, and then finally going back to 2 pi, you get 0 again. So that is the main shape, and that's what you need to remember. Okay, so it reaches the highest point at 1 and the lowest point at -1. All right, now for the sine of cosine, for the graph of cosine, you can do exactly the same thing, meaning you can make a table of values, just like we did for sine, and start plotting a bunch of points until you get to the basic shape of the cosine function. And here's the basic shape of the cosine function. This is again the graph between 0 and 2 pi. Between 0 and 2 pi. So the graph of cosine starts at 1. And again, the graph doesn't really start at 1 because it goes on forever to the left and to the right. But this piece, the main piece that you have to remember, the piece that repeats itself, starts at 1. So that means cosine of 0 is 1. Cosine of 0 is 1. Then at pi over 2, you get 0. Then at pi, you get -1. -1, all right. And then at 3 pi over 2, you get 0. And finally at 2 pi, you get 1. And that's the entire graph of the piece that you have to memorize. The entire graph is actually repeats itself to the infinitely many times to the left and to the right. It is the same basic shape. It is a wave. All right, so we'll be coming back to that basic graph. So this is the graph of y equals cosine of x. All right. Here's the main properties, some properties about the graph of sine and cosine functions that you do need to know, and it is helpful for later sketching the graphs of transformations of sine and cosine. So, as I said, the shape of the graph of both sine and cosine actually repeats itself after every 2 pi. So that means that if I start at 0 and then once I reach 2 pi, after this point it's going to repeat itself exactly. So it's going to go back up and then down. So up and down, and just like that, wave is going to repeat. And similarly to the left, right? So between 0 and 2 pi is the main part, and after that is exactly the same thing. So it repeats itself after every 2 pi. And there's a word for that. When a function repeats itself, we say that the function is periodic. And then the interval that it takes for the graph to start repeating itself, the length of that interval is called a period. So the sine and the cosine functions are periodic with period 2 pi. Okay, so a function is periodic in general with period p if, in terms of the graph, means it repeats itself, but in terms of the equation of the function, that means that when you plot at p, or in the case of sine and cosine 2 pi, when you add the period, you get exactly the same thing as if you hadn't done anything. So adding the period doesn't really do anything because it brings you back to a repetition of the graph, right? So in particular, since both sine and cosine are periodic with period 2 pi, that means that when you add 2 pi to the cosine inside, you get exactly the same thing. So cosine of x plus 2 pi is exactly the same as cosine of x. And sine of x plus 2 pi is exactly the same as sine of x. And the explanation for that is, going back to the unit circle, It's because if you have an angle, right, what are the coordinates of that point? Let's call this angle T. Is a unit circle. What are the coordinates of this point? Well, the coordinates of that point are just the cosine and the sine of T. Now, if I add 2 pi to this angle, what happens if I add 2 pi to this angle? If you add 2 pi, well, that's a complete full revolution. So if you add 2 pi, you're going to end up in exactly the same spot. So if you add 2 pi, you're going to end up in exactly the same spot, but the coordinates of that point are cosine of t plus 2 pi sine of t plus 2 pi. But because you end up in exactly the same spot, that means then that cosine of t equals cosine of t plus 2 pi and sine of t equals sine of t plus 2 pi, which is precisely this statement right here using the letter x instead of t, but that's irrelevant. All right, okay, so they're periodic with period 2 pi. The tangent function also happens to be periodic, but the period of the tangent function is actually pi. And we will talk about the tangent function later. This lesson is just only about sine and cosine. All right, so here's the basic graphs of sine and cosine drawn a little bit further past the interval from 0 to 2 pi. So you see it starts all over again and goes on forever to the right and to the left, repeating itself. And this is one period between 0 and 2 pi. Sine starts at 0, ends at 2 pi. This is the graph of cosine. One period starts at 1 for the y coordinate. Cosine of 0 is 1. And then ends at 2 pi because the period is 2 pi, as we just said. And repeats itself to the left and to the right. All right, some more properties of sine and cosine functions. The sine and cosine functions have several distinct characteristics. Both functions are periodic with period 2 pi. The domain of each of the functions is from minus infinity to infinity, or all real numbers, and the range is -1 to 1. Remember, the range is like the vertical span, how far up the graph goes and how far down. Well, the entire graph forever from minus infinity to infinity is completely contained between 1 and -1. The graph does not go higher than 1 or lower than -1, but it does reach both 1 and -1 of those maximums. Maximum, minimum, maximum, minimum, maximum, peak, valley, peak. All right? And the same is true for the graph of cosine. The entire graph of cosine is completely contained between 1 and -1. That's the range. The graph goes between, or oscillates between -1 and 1. The graph of cosine is symmetric about the y-axis. So here's the graph of cosine. It is symmetric about the y-axis, and remember that that's because the function is even. You learn in college algebra that when a function is even, it is symmetric about the y-axis. And we discussed before that cosine is even. And the sine function is odd. And odd means in terms of the graph that it is symmetric about the origin. It is symmetric about the origin. So it's like that is the point of symmetry right there. Okay, so remember that even means the we plug in a negative, it's the same as that. Cosine of negative x is the same as cosine of x, and odd means that you can push the negative to the front. Okay, one last thing about sine and cosine functions before we start drawing pictures. So transformations of sines and cosine functions are called sinusoidal functions. So it is just a transformation of either a sine or a cosine. And these are graphs that share the same general shape, the same wavy shape as a sine or a cosine. And the two general forms are a sine of bx minus c plus d if it is a sine wave, or g of x equals a cosine of bx minus c plus d if it is a cosine wave, where we assume that b is positive, okay? B is positive. If B was not positive, if the coefficient of the x is not positive, then you can deal with it using the properties of sine of odd and even. So for example, if what I had was something like that, 2 sine of negative 3x, then using the properties of even and odd, in this case, sine is odd, you can just put that minus in front and say 3x, and that way you have the coefficient of the x be positive. Or if you had, I don't know, a cosine, then using the properties of cosine, the fact that it's even, you can say that this is the same as cosine of 4x. And that way, again, uh, the coefficient of the x is positive. So we're going to assume, because we can always do this kind of thing, we are going to assume that we got, if there wasn't a negative, we got rid of it, and that therefore the coefficient of the x is positive. Okay, now because these functions are just transformations of sine and cosine, meaning is a function that you have modified by making some changes, some transformations as you learn in college algebra. You move the graph up, down, left, right, you stretch it, you shrink it, those kind of things. Doing any of those kinds of motions or transformations doesn't really change the shape of the graph. So that means they're also going to be wavy, and they're also going to repeat themselves forever. They're also going to be periodic. All right, and because they're periodic, they have a period. But the period of a transformation is not necessarily 2 pi, okay? Because if you shrink the graph, it's going to repeat itself more frequently. So let's say this is like the basic shape. If you shrink the graph, you compress it like this horizontally. Okay, this is a terrible picture, but you get the idea. Then it's going to start repeating itself more sooner. It's going to start repeating itself sooner. So in this case, this graph will start repeating itself after whatever that is. So if this is 2 pi, maybe we could say that this is some other number. It's going to start repeating itself much earlier. So the period is actually smaller. So what is the formula for the period? The formula is this, and you're supposed to memorize this, okay? The period of a sinusoidal function is given by 2 pi divided by b. B being the coefficient of x. So memorize that. The period is 2 pi over b. We won't be talking much about the frequency, but you hear uh, about the frequency in applications in physics because electromagnetic waves and all sorts of um, phenomena in physics that have this wavy shape can be modeled using trig functions, you talk about the frequency. And the frequency is just the reciprocal of p, okay? We're not going to use that, but it is the frequency of p if you see it in a physics class in the future. The reciprocal of p. All right. The number d in the basic formula. So the b helps you get the period. The d gives you the vertical shift. Okay, so that's not different. There's no difference between what you learn in college algebra and what I'm talking now. The d is the vertical shift, whether the graph moves up or down. So if it was a +5, that means it moves up 5 units. If it was a -5, that means the graph is shifted down 5 units. Okay. Now the line y equals d is a horizontal line called the midline, and it is the line that passes right through the middle of those waves. Passes right through the middle. Okay, so if you have a shape like this, a graph like this, let's say my graph is actually shifted up, then the equation of the line that passes right through the middle of all the waves is called the midline and has equation y equals d. So that's what that d also gives you. So the d tells you two things. The d is the vertical shift, how much the original graph is moved up or down, but the equation y equals d also gives me the equation of the line that passes right through the middle. So the d serves two purposes. Okay. Okay, so that helps explain the b, the d. How about the a? This formula, what does that give me? Well, the a turns out to be the so-called vertical stretch factor. And the absolute value of a is called the amplitude. Okay, the absolute value of a is called the amplitude. And the amplitude is the distance between the midline and the highest point, or because this is symmetrical, it could be the distance between the midline and the lowest point. So it is that distance right there. Okay, between the midline and the highest point, or between the midline and the lowest point. So it is how tall that wave is. That is the absolute value of A. That's the amplitude of the wave. Okay, that's another thing you have to memorize. What that the absolute value of A is the amplitude and what it means. And finally, oops, there's a little typo there. Finally, the phase shift is given by C over B. Okay, memorize that as well. C over B. So I'm dividing C over B. And note that I'm dividing, even though there's a minus here, is minus negative C. I'm dividing by is the positive C. So in general, it's going to be the opposite of whatever sign you see here. If you see a minus, it's going to be a positive. If you see a plus here, if you set plus C, you're going to put minus C over B. All right, it's the opposite of what the sign that is in here. This is a minus C, so I'm going to put here positive C over B. All right, so that is the phase shift, and it is how much, it is the horizontal shift, how much the graph moves to the right or to the left. If the sign is positive, that means you're moving to the right. If C over B is negative, that means you're moving to the left. All right, and here's some graphs that shows examples of the basic graph with different amplitudes. So this one is 1 sine x, 2 sine x, so the wave is twice as tall, 3 sine x, so the wave is 3 times as tall, and 4 sine x, so the height of the wave is 4 times as tall, so 4 units. Okay, let's put all of this together and given some sinusoidal functions actually find all this stuff. So here's the first example. Determine the amplitude, the period, the phase shift, the midline, and the vertical shift of this function right here. F of x equals 3 sine of 2x plus 1. Okay, let's start with the amplitude. The amplitude is actually the absolute value of a. And a is the coefficient in front of the sine or the cosine. So in this case, the a is 3. So that means I'm talking about the absolute value of 3, which is 3. So the amplitude is 3. And remember, that means that is the height of the wave. All right, what else? So the amplitude is done. Period. Okay, this is a formula. Remember that you have to memorize this formula. The period is 2 pi over b. The period is 2 pi over b. So this is 2 pi, and the b is, what is the b? The b is whatever is in front of the x, is the coefficient of x. So the coefficient of x here is 2. So that means 2 pi over 2, and that is pi. So that means the graph of this thing is going to repeat itself every pi. After every pi, the graph repeats itself, both to the left and to the right. All right, so that's the period. What else? The next thing that we need to find is the phase shift. Phase shift. Okay, the phase shift formula is, again, memorize that. The formula is C over B. And remember the comment about the sign being the opposite. So the phase shift is C over B. C here in our example is 0. There's no C. So this is just 0 over 2, and this is just 0. So that means the graph, the original graph, is not being moved either to the left or to the right. So you can say the phase shift is 0, or you can say there's no phase shift. No phase shift. Okay. And finally, there's 2 more things. The midline. Okay, the midline is just the equation, just a line with the equation y equals d. So remember that. And the d here is 1. So that means y equals 1 is the equation of the midline, the line that passes right through all the waves. And lastly, the vertical shift. So the vertical shift is the d as well. Remember, the d serves double duty, but the interpretation is different. So in this case, the graph is shifted up 1 unit. You could say shifted 1 unit upwards. All right, and that's it. Okay, let's do another one, or maybe you should try this one on your own if you got all that. So maybe you should pause the video and try to do all of this for that one. Okay, let's do it. So amplitude is the absolute value of A. And what is the A? The A is the coefficient in front of the sine or the cosine. Okay? In this case, it's -1. So the absolute value of -1, which is 1. So the amplitude in this case is 1. That means that the height of that wave from the midline is 1. All right, next thing, period. The period, the formula is 2 pi over b. So we get 2 pi over 4 because b is the coefficient of the x, so that's 4. And then simplifying, this is pi over 2. Next, phase shift. The phase shift is c over b, that's the formula. And in this case, the c, remember, is the opposite, so I see a -2, I'm going to put +2. The c is 2, and the b is 4. So this is 1/2. So in words, this means that the graph, the original graph, the basic graph, is shifted half a unit to the left. I mean to the right, because it's positive. Or shifted to the right half a unit. Then midline. The midline is y equals d. That is the equation of the line. But d is -3. So that means y equals -3 is the equation of the line that passes right through the middle of the graph. And then finally, the vertical shift is again given by the d. It's -3, so that means the graph is shifted. The basic graph, the original one, is shifted 3 units down or downward. And that's it. Now, for the next examples, we're going to put all of this together and learn how to use it all to sketch the actual graph of whatever sinusoidal function they give us.